Hello students! Welcome to a new video tutorial on number representation. This lesson explains why binary and hexadecimal are used for data representation. Let's have a look at the contents of today's lesson. In this video lesson, we will start with a recall part to remind us about our denary number system, explain the binary and hexadecimal number systems while learning how to convert between different number systems. We shall discover how hexadecimal is useful for data representation, and finally, we shall end the lesson with a recap. A number system is a system of counting and calculating. A number system is based on some characters called digits. A number base indicates how many digits are available within a numerical system. We will study three number systems: decimal or denary number system, binary number system, and hexadecimal number system. In everyday life, we use numbers based on combinations of the digits between 0 and 9. This counting system is known as decimal, denary, or base 10. The denary number system is the most common number system. Using the denary number system, 3, 1, 4, 0 reads as 3140. Each digit is worth 10 times the digit before it. That is, it counts in multiples of 10. Similarly, 5, 3, 1, 9 reads as 5319. Time to test yourself. Break down 5, 9, 7, 3 in terms of its units, tens, hundreds, and thousands to show its representation in the denary number system. Five, 9, 7, 3 means 5973. The binary system is the number system that computers use. It operates in base 2. It is based on the number 2. So, we use only two values, 0 and 1, to represent all values in this system. The binary number system is used to store information on computers using electrical pulses. The number 1 represents a pulse being on, and vice versa. It allows computers to carry out complex calculations efficiently. Each digit is a bit. Using the same method as the denary number system, we use the headings 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. Each column is worth 2 times the amount of the previous column. A typical binary number would be 111011110. To calculate a large binary number like 10101000, we need place values of multiples of 2. Then, we sum up the values of each digit in the binary number multiplied by the corresponding power of 2. In the same way, to calculate the denary or decimal equivalent of 10110111, we sum up the values of each digit in the binary number multiplied by the corresponding power of 2. 10110111 is 183 in decimal. Let's see if you have understood. Question number 1. Convert 1111101 to denary. It becomes 125 in denary. Question number 2. Convert 01101010 to denary. It becomes 106. Conversely, how do we convert denary numbers to binary? We will use the method of successive subtraction of powers of 2. Remember that 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 3 gives 8, and so on. If we had a denary number of 68, we would find the highest number that would fit into 68. Can 128 fit into 68? No, we place 0. Can 64 fit into 68? Yes, we write 1. We are left with 4. Can 32 fit in 4? No. Can 16 fit in 4? Still no. Can 8 fit in 4? No. Now, can 4 fit in 4? Yes. 4 minus 4 gives 0. So, we fill in 0 in the remaining cells. Hence, 68 can be represented as 01000100 in binary. Let's take another example. Suppose we have the denary number 84. To convert it to binary, we would again set up our columns with powers of 2. That is 1, 2, 4, 8, 16, etc. Then we look for the highest power of 2 that goes into 84. The highest power of 2 number is 64. 84 minus 64 is equal to 20. Then we find the next highest power of 2 that goes into 20. The highest power of 2 number is 16. 20 minus 16 gives 4. The next highest power of 2 number that goes in 4 is 4. 4 minus 4 is 0. Therefore, 84 in denary is equivalent to 01010100 in binary. To verify if you have well understood, note down these questions to be done later. After you have worked them out, these should be the answers that you should obtain. We often have to deal with large positive binary numbers like this. What could be the problem of working with large binary numbers? The major disadvantage of binary number is that it is difficult to read and write for humans because of large number of binary of an equivalent decimal number. Fortunately, large binary numbers can be made much more compact if represented in base 16, the so-called hexadecimal number system. The hexadecimal number system is a base 16 system and therefore has 16 digits, 0, 1, 2, 3, up to 9, letter A, B, C, up to F. Using the same method as for denary and binary, this gives the headings 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3, and so on. A typical example of a hex number is 21F3A. Since 16 is equal to 2 to the power of 4, this means that 4 binary digits are equivalent to each hexadecimal digit. The table given summarizes the link between binary, hexadecimal, and denary. Using the table given, the binary number can be converted into an equivalent hexadecimal number of D5CF, which is much easier to read and understand than a long row of ones and zeros that we had before. Let's take a second example. The binary number 01010111 can be converted into an equivalent hexadecimal number of 57. Time to put pen to paper. These are the results that you should obtain. To convert a hexadecimal number to a binary number, we reverse the previous procedure. We separate every digit of the hexadecimal number and find its equivalent binary number, and then we write it together. Now it's your turn. These should be the solutions obtained. After we have obtained the 4-bit code for each digit, we put the groups together to form the binary number. To convert a hexadecimal number to a decimal number, we write the hexadecimal number as a sum of powers of 16. For example, considering the hexadecimal number 1A9B, we can convert this to denary like this. In the same way, the hexadecimal number 1AB can be converted into its denary equivalent as shown in the diagram. Copy these questions and their corresponding answers to check for your understanding later on. Four 5A becomes 1114, while C8F becomes 3215. To convert denary to hexadecimal, we use successive division by 16 until the value 0 is reached. Suppose we have to convert 2545 from decimal to hexadecimal. We will start by dividing 2545 by 16. This gives us 159 with a remainder of 1. 159 divided by 16 gives us 9 with a remainder of 15. 9 divided by 16 gives us 0 with a remainder of 9. So, we can say that denary 2545 is represented as 9F1 in hexadecimal. Put yourself to the test with the following questions. Here are the answers. A computer can only work with binary data. Then, why do scientists find hexadecimal more convenient to use than binary? It is because one hex digit represents 4 binary digits. A complex binary number such as 100, 100, 111, 1011, 110 can be written as 93DE. The hex number is far easier for humans to remember, copy, and work with. Hexadecimal is translated into binary for computer use. Some examples of where hexadecimal is used include color representation in HTML, MAC addresses, and assembly language programs. HTML is used when writing and developing web pages. Colors are defined in HTML using the given hexadecimal format. The hash symbol indicates that the number has been written in hexadecimal format. The values for each color run between 00 and FF. The Media Access Control MAC address is a binary number used to uniquely identify computer network adapters, that is, devices on a network. They are usually written as 12-digit hexadecimal numbers. The leftmost 6 digits are associated with the adapter manufacturer. The rightmost digits of a MAC address represent an identification number for the specific device. Assembly language and machine code are low-level languages that directly access the memory chips in the computer. They can be useful when writing programs or when carrying out troubleshooting. But using true machine code, that is binary, is very cumbersome and it takes a long time to key in the values. It is also very easy to mistype the digits in a sea of ones and zeros. Using hexadecimal makes it much easier, faster, and less error-prone to write code compared to binary. In today's lesson, we learned 3 different number systems, namely binary, denary or decimal, and hexadecimal. We saw that digits from one number system can be converted to another number system. We also appreciated the differences between the number systems. Thank you for watching. I hope you have enjoyed this lesson. Come back soon for more videos.